Hello viewers, welcome to our channel LetsMasterCS. Today we will be learning about time complexity analysis of algorithms. If you are new to our channel, please subscribe to our channel. We post regular videos on different topics of C programming, C++, and algorithms and data structure. Let's get started. First, we will learn about how do we calculate a time complexity. Time complexity is the one of the main feature for analyzing an algorithm. How fast, how good, how best your algorithm can perform. In current day where data is everything and we talk about artificial intelligence, robotics, where millions and millions of data are to be processed in fraction of seconds, the time complexity analysis plays a vital role. In this lecture, we will understand how do we calculate time complexities of different programs. Later on, which can be used for enhancing the performance of the algorithms. Now, let us take this basic example. This is a part of a code which is written in C. The initial lines, the hash include, the main are not mentioned over here. We are just bothered about the main portions of the code, which is given under the main function. Over here, we have the first line as the declaration of the variables, then initialization of the variables and adding up values, and then finally printing the result. Let's see how every line is being calculated at what instance of time. Every line takes 1 unit of time. Together, they make it a 6 unit of time. Now, this 6 unit can be represented as the constant value. Now, I have never said that it is taking 1 second, 1 millisecond, 1 hour, or 1 day, or even a 1 year. I said 1 unit of time. Why this 1 unit of time I am referring to? The actual time is taken by a specific instruction to execute for any kind of algorithm depends on the number of processes the CPU is handling at that particular moment and the power of the central processing unit. Along with the room temperature also makes an impact on the actual time. So what we calculate in terms of unit of time. Over here we have calculated 6 unit of time, and each time the algorithm or the program executes, it will take 6 unit of time, no matter the value of A is 5 or 15. It doesn't matter if the value of B is 16, not 6. So it does not depend on the number of inputs. So we do not have a variable time complexity. So we have constant time complexity, which is represented by C. Now this constant time complexity only is represented by order of 1. The order is represented by O, capital O within bracket the time complexity. So the time complexity for this particular program is order of 1. Now let's see an example of a loop, how much a loop takes for a time complexity. So over here we have for I equals to 0, I less than n and I plus plus. By the for loop we can understand that the statement will be executing exactly n times. So the time complexity of this particular program will be order of n. Obvious reasons, the program will not only contain only one for loop, will contain maybe other couple of steps which will be added. Say for example, order of n plus a constant value. In that case, for a greater value of n, we might ignore the constant value. Say for example, n is the number of inputs. Number of inputs is 1 lakh. So 1 lakh and 1 lakh 6, where 6 are the cumulative time complexity of other statements, doesn't actually makes a big difference. So we will be naming that time complexity as order of n. We can have the reverse one as well. I starts from n and goes up to 0. The same thing happens in the similar logic and the similar fashion. Time complexity will be calculated as order of n. In this case, the value of I does not change by 1, it changes by 2. So the statement will operate n by 2 times. In this case, the time complexity would be ideally order of n by 2, but as similar to the previous one, since n by 2 is also a polynomial of n, so the time complexity would be order of n. Let's consider a nested loop. Over here there are two loops. One is outer loop, which is being controlled by the variable I. One is the inner loop, which is being controlled by the variable j. The outer loop goes from 0 to n. The inner loop also goes from 0 to n. The statement will execute n into n times. Let me explain why. For every value of I, the j will be rotating n times. As the value of I will rotate up to n, so the value of j will also be changing n times for each value of I. So total number of value of I is n and total number of value of j is n into n. So the statement which executes n into n times. So the time complexity for this particular statement is order of n squared. Now let us consider this particular nested loop where the outer loop goes up to 0 to n, but the inner loop goes up to 0 to I. In this case, the value of I will be 0, that time value of j will be also 0, and since the j is less than I, the statement will not execute. Similarly, when the value of I becomes 1, for value of j equals to 0, the loop will rotate one time. Similarly, if we can go on, we will find out that for value of I, which is obviously it will be less than n minus 1, value of j will go up to n minus 2 and the number of times it will rotate will be n. So which makes it the time complexity something like this: 1 plus 2 plus 3 up to n, which is n into n plus 1 by 2, which can also be expressed in terms of n square plus n by 2. Now if the value of n is too big, then the value of n is negligible in respect of n square. So the time complexity would be order of n square. Next, suppose there is a variable p equals to 0, j is 1, the loop depends on the value of p, and we have j plus plus, and instead of a statement we have p equals to p plus j. Now with the value of 1 for j, the value of p is 0 plus 1, then the value of j equals to 2, the value of p would be 1 plus 2 equals to 3. If the value of j equals to 3, then the value of p would be 1 plus 2 plus 3. If the value of j equals to 4, then the p will be 1 plus 2 plus 3 plus 4. If the value of j equals to k, then we have 1 plus 2 plus 3 plus 4 plus k, which again will result into k into k plus 1 by 2, assuming p is a greater value than n, because the loop will exit if the value of p is a greater one, which obviously means that k into k plus 1 by 2 is greater than 1, which means k square is greater than 1, which means k is greater than equal to root over of n. So the time complexity for this particular algorithm would be order of root n. Next, the time complexity where the parameter based on which the loop operates is incremented in a double fashion. So over here the loop runs from j1 to n, having j equals to j multiplied by 2. In this case, the value of j will be initially 1, then it will go to 2, then it will go to 4, then it will go to 8, then it will be going to the power k. We can express it in terms of the first value as 2 to the power 0, then the second value as 2 to the power 1, third value as 2 to the power 2, fourth value as 2 to the power 3, and then 2 to the power k. So this can be expressed assuming that the value of j is greater than n, then we can have j equals to 2 to the power k, because that is the maximum number of times the j loop will rotate. So j can also be expressed in terms of 2 to the power k. So 2 to the power k can also be expressed in terms of greater than equal to n. Then we can say that 2 to the power k is equals to n, and we can say that k equals to log base 2 n, which can be expressed as the time complexity of order of log base 2 n. This order of log base 2 n time complexity can also be found while doing the binary search. You can check the description link for the binary search time complexity analysis. In a similar fashion, instead of j equals to j multiplied by 2, you can also have j equals to j divided by 2, where j starts from n, goes up to greater than 1. The same way you will find out that the algorithm is giving you the time complexity in logarithmic terms. Thank you for watching. I hope you have liked the video. If you have liked the video, please like, share and subscribe to our channel.